Cluster analysis. Cluster analysis is used to group together cases using the values of the variables. So let's go ahead and get our data set, which is going to be vcr.save. A VCR is an old taping machine, and here they're identified according to different characteristics. So there's a Unicode request. This data is recorded in a data set in a particular way, and so you have to say yes when SPSS queries you whether it can import it. So these are made up names of brands that don't actually exist but are similar to real brands. And you can see here the price, pictures, programs, audio, features, remotes, a lot of extras. So it basically has a whole bunch of product information. In fact, there are more variables than there are cases. So again, you have to be wary how this overcomes the degrees of freedom problem. So the model attempts to incrementally associate together different VCRs based on their characteristics as described by their independent variables, and proceeds through the full continuum from each item in its own class into grouping all of the items into one class and all of the progressively aggregating classes in between. The basic math logic is cluster analysis uses the squared Euclidean distance to gather like cases together, and can do so from the parts to the whole, which is agglomerative hierarchical clustering, or the whole to the parts, which is divisive hierarchical clustering. So let's go and run a cluster analysis. So we go to Analyze, we go to Classify, and we go to Hierarchical Cluster. Now into the label by cases, label cases by, we're going to put in brand, okay, which is the name of the different products. And then we're going to insert all of the independent variables into the variables block. Now we're then going to select here cluster, and we're going to ensure that cases has been selected. And under display, we're going to make sure that plots is selected. And then we're going to go up here to the top, and we're going to, under plots, and we're going to select a dendrogram. Now there are instances where you can modify the icicle, and you can specify the range for the different clusters for values of what to include and what not to include. Now ensure that the dendrogram orientation is vertical, and then click Continue. Then we go to Method, and we're going to choose the cluster method, and we're going to choose the furthest neighbor. Again, these are values I chose by looking at the literature of this technique, both within SPSS and additional sources. So the measure is going to be interval, and it's going to be the squared Euclidean distance, which is the default. And then we're going to go down here to transform values. We're going to choose z-scores and choose it by variable. Then we click Continue, and then we go up to Save, and we save a single solution with 3 clusters. Then we click Continue, and we run this. So here, the first table is the Agglomeration Schedule, and it shows cluster 1 being added to cluster 2. And the coefficient is the squared Euclidean distance. So at the different stages, it shows you which cluster is combined with which cluster. So it builds up and then builds down the association between the different products. This here is the vertical icing plot, and it shows how each of these products is associated, and this has been saved as a variable on the data set, clue3_1. And probably the most easy to understand table is the dendrogram. And here you can see different clustering of VCRs. You have sort of one cluster here, one cluster here, and one cluster over here. So this is cluster analysis.